way and have a look at. Yeah, so welcome back to today's Python workshop. What we have for today is just a completion of what we started on, I believe, on Monday. The discussion for today is going to cover the completion of the app in terms of one or two technical details with regards to the data structure, with regards to the function structure, and lastly, with regards to how to understand the data that comes out of the whole app that you develop. So that will be the first part of today's discussion. And then, as I promised on Wednesday, we'll finish with the AI, trying to understand how it works and trying to formulate our own AI and see whether we can make sense of what's going on. So that's the outline for today. So just a reminder, for this workshop, what we tried to do was to create an app to compute our mathematical and investment decision for us. And I think we did that for the past 2 days. We also inculcated within the app the fact that we have an advertisement decision to be made, and by using our functions, we are able to capture this as well. And then we are able to use the function to take decision from individuals. I think we did that on Monday as well as on Wednesday. And we also had in mind the objective of having an AI that will help us develop a very simple, naive algorithm to match the data that we collected. And I gave you guys an idea as to how I would develop an AI of this nature on Wednesday. So today, we spend much time on this, hopefully during the second part of our meeting. And then we also indicated that we wanted to send our app out for individuals to try. And I took you through the steps on Wednesday, from the very first to the very last step, and that will help you send your app out. So all in all, I think the objective has been met, given the fact that we have an extra time for today to work more on the AI. So that's the first part of today's discussion. Now, in terms of today's meeting, I have a very simple idea in mind, and that is to take you through the app again. One or two things that I was pretty much silent about, they look a bit technical, and it was more or less like a black box for us. I will try as much as possible to make it clear, so that at the end of the day, you understand all the steps that are involved within your app development. And I'll also show you one or two links that might be useful in understanding this. And then I'll show you the data that we collected from Monday and Tuesday, given what you guys did. You have your names there, and then you have the results that the app gave us. It's also available. I'll show you guys the data. And lastly, we'll look at the AI itself. So that'll be the structure for today's meeting. If you happen to have any concern, any question, just let me know as we go along. Now, to start with, I'll start by looking at going back to the usual pages that we were accustomed to from Monday up until now. So we realized that before you develop an app, there's a need for you to have a model. And then you go on to having a page. Then finally, you transfer your data either from your page to your HTML or from your model to your HTML. So that was a structure that we saw. The very first file that we came across was obviously the models. And within the models, one thing was a bit important in terms of the structure. So we realized that we need a class player, that is the player involved. These guys here, I believe, might sound a bit, we didn't discuss it. So in terms of the data structure, there's a need for us to know the type of information that we need from the participant. So when we ask for the participant's name, because he types maybe Farouk, which is FA, till the end, we call it a string, just like what we started on Monday. So any data that comes in the form of letters is called a string. So given the fact that the name is specifically typed and is in the form of letters, which is a string, then we need to modify it and call it a string. So email address is a string. The name that he gives is also a string. Now, in terms of the second type of data set that we saw from the beginning, which happens to be numeric, an example being your age or how many times you go to school a day or what's not. This is called either a float field, and that's what you see when you go to Heroku. When you go to Heroku and trying to understand the type of data that we have, this makes it much clearer. So you can either have a string field, which is purposely for text, which we saw here when we gave the name, or you can either have a float field, which takes real numbers, and that's what we see whenever we compute for quadratic equation, or you can also have something that we call integer, which is the usual integer. Now, this guy is also really interesting. For instance, you like someone to write a whole comment about your product. So with that, instead of using just a string, which is very short, you might want to use long string form to have that space for comments. So that's one thing you have to keep in mind. So back to these models, if you go back to your model and you want to develop your app and you are interested in getting the data, just keep in mind the type of data that you are about asking for and where it falls. So either it falls within a string field or within a float field or within currency or within whatever field that might be given to you somewhere here. So that'll be the first part of today's discussion. If you have any question in there, just let me know in terms of getting to know the structure of the data. So that will end everything that you need to know about the models if you have a very simple app for just an individual. Now, let's go back to the pages. You realize that I was a bit silent on this guy here. This is class, this is a class. So what class does is a very simple idea. So we started by developing a function and getting to know what the input is and what's not. A class has the same idea behind it, but here you are putting the function within the class itself. It's more or less like structuring it below that particular classification. So this is also important. So for you to understand class, I posted on my website, I think on Wednesday, how to understand class and how to make sense of it. So you can just go to my website and click on class. It's just the same idea, very simple idea. If you know what a function is, if you know what an attribute is, if you know what an input is, which is the same as attributes here, then it's just easy for us to work with. So whenever you come to your pages and you see class, don't be confused by it. Just think about it in the form of a function form and just read this, this link, more about classes, and you should be fine. Now, having said that, you can quickly go back to your models and realize that the classification has also been done in terms of classes. Either you have a class player or class group or class subsession or class constant. So it's the same idea, nothing so important. So just keep that one in mind. If you have to see class within your pages or your models, that's what it means. A bit of reading might help in terms of the link that I give. Now, lastly, in terms of your form field, in terms of your pages, you realize that for any page that you created, you are supposed to ask for the individuals, whether it's an individual, which is a player, or whether it's a group, which is, you put a group there. So this is what we did in terms of the quadratic equation, and we discussed that on Wednesday. Now, what I would like you guys to pay attention to here is the function that is needed. So an example here is, I would like to draw your attention to this guy here. So our app asks you whether you want to compute a quadratic equation or you are interested in computing an investment decision. So let's take the situation where the individual has made his mind to use the quadratic equation option. So this is what we have. The individual is supposed to give us what the ax squared is, which is the a-intercept. Maybe we might take it to be 2. It's supposed to give us what the b is. You might want to take it to be 1 or whatever number you think is okay. And you might want to ask him for the constant as well, which is a c, for you to complete your quadratic equation, which you might want to take it to be 4. So these are the input that are needed. Now, as an app developer, you have to come in and do your own math to show the results. So how does that work? It's a very simple idea. The same function that we developed back on Monday is the same idea we are going to use here. So we realized that on Monday, we had an idea as to how to compute a quadratic equation and all that. And we started by saying that you define what the function is, what it takes, and all that. Now, the self that you see here shouldn't confuse you. It's just basically because it falls under a class, there's a need for you to write a self here. So that should be okay. When you read more on the classes, you wouldn't be bothered about the self. Now, what is most important here is the fact that for every function, there is an input. So back to what we saw here, the input that we expect to see here is the A, B, and C. So when you come here, for sure, you've asked for the participant to give you his A. So here, you have the player dot A coefficient. So this is basically the coefficient that the person gave. In my case, I gave 2, so it's going to be 2 that will be placed here. Then the next one is a B coefficient, which I gave to be 1 back on my page. So you have 1 here as well. And lastly, C, which is a constant, it's also here. Now, this is where your math comes in. You have to write a function that will do a very simple math. Now, the good news here is we know how a quadratic equation is being computed. It says minus B plus or minus the square root of B squared minus 4AC all over 2A. So this is a function that captures that. So when you do that, this is just you writing the formula in a standard form. The B has already been given to you by the player. The A has been given to you by the player. The C has been given to you by the player. So at the end of the day, you can nicely use this function to compute the results. So if you are able to do this, then you are okay. So when I use your app and I give these functions and I click next, let's see what comes out of it. My app has been able to inform you as to what your A is. And that was very simple because I asked for the return of the A coefficient, right? So when you go to my results page, you realize that it's given to us here. So remember the transfer of information from your pages to your HTML, just like what we did on Wednesday. So when you come here, this is the information that you have. You want it to be transferred to the results page, which is A coefficient. So when you come to the results page on HTML, the double curly brackets, you put it there. So the person will see the coefficient that he or she gave. The same thing applies to this guy here. The B coefficient, you've asked for it to be returned from your pages to your HTML. So it will do the same thing for you. And lastly, you ask for the C coefficient to be returned to your HTML, which is given to us here. Now, in terms of the results, this is the result that you compute for the person. So when you come back to your pages, you've asked Python that everything that you see from here till the end of the equation should be labeled as positive, or the final result, which is positive. So when you copy this and you come to your pages, you just paste it within the curly bracket. Now this part will take care of the positive results for you, and you can label it. You can label this guy as well any name. But most importantly, just make sure it's consistent in terms of you transferring it from here back to this side. So we have this guy also given to you nicely as your final result, which is negative. And that would just be it. So here we have our results page being given to us. One thing I would like you guys to pay attention to is that when you come to this results page, you realize that we didn't ask for any form field. So back to this side. For every page that we have, we write form model and we also write form field. But when you come to the results page, we didn't write that. And the answer is very simple, because here within the results, there is nothing that we expect the player to give us. So given that we don't expect any information to be given to us by the player, then there is no need for us to write this guy when we go to the results page, right? So if you have any questions there, just let me know. So if you have any page in mind and you don't need any information from the participant or from the player, you can just do away with the form field because you don't need it. You don't need this guy, neither do you need this guy. You don't need them. So that's why when you come to the results page, you don't see them here. So that will be just about it. And at the end of the day, when you go back to my my website and you copy all the files here, this will be the complete models file. This will be the complete pages file. And this will be the complete HTML folder that you need. If you copy everything and you run your code, you should be fine. If you want to send it out, you can just copy this guy here as well, follow it step by step, then you can put out your code out. So this is by way of getting everything sorted out. If you have any confusion as to what this means or what that means, I hope by now everything is clear now. So if you have any questions, just let me know and hopefully I can be of help. So just by way of reminder, what I tried doing in 20 minutes for today was to introduce you guys to classes, which is a very simple idea to understand. So whenever you see a class, think of it in the line of functions. You shouldn't be confused by it when you see it in oTree. Now, the next thing I talked about is this guy here, the type of data sets that you'll be asking from the player. Either you need the data to be a string, or to be a float, which is a raw number, or to be an integer, or to be a long string field, which takes care of, very long statements. And lastly, the fact that we can transfer our data from our pages to our HTML and getting to know where to put the functions that run our results for us. So that will be it in terms of understanding this. And this guy here, round, is just rounding up the figures to the nearest integer or to the nearest 2 decimal places. So when you see round with 2 here, it means I'm going to round the figure that the person gave to the nearest to the 2 decimal places. If I round 1, then it will be 1 decimal place. If I write 3 decimal places. So don't be confused by that as well. If you have questions, if you have any concern, just let me know. Go through the entire folder and let me know if you have any concern as you go along those lines. Now, having done that, I will then close the chapter on the app development. If you have questions, let me know. Raymond, any question in there?
No questions.
Okay, good. Now, the next line of action is to retrieve our data, have a look at how our data will look like and how to play along with it. So I've already retrieved our data, and this is how our data looks like. When you go to Heroku, I don't want to open my app now I don't want to open my account now due to sensitivity. So when you go to Heroku, you just click on the app and you click on the data, and it will just show you what the data is. Either you want it in CSV or you want it in Excel. If you do that, you end up with something like this. So at the end of the day, when I went into my my folder, I realized that these are the individuals that tried the app. So I have Stacy, I have RG, I have AUA. These are initials that were given, and these are your decision across the 4 dimensions in terms of whether you wanted a fixed decision or whether you wanted a random decision. So for these guys here, that is starting from Stacy down to Stephanie, they chose fixed decision for the first time. Then I think Hank changed his decision for the second round. He changed it again to random, and he finally changed it to random. So this is how to capture the information whenever you develop your app. One thing you have to keep in mind is if you are interested in getting to know, for instance, what is the name that was given, is very simple. Remember, when you go to your form field to get the name you said was name underscore initials underscore consent. So when you download your data, just look for the column that counts with the same thing. In addition to that, it counts with player, right? Because it's the player information. So here is player.name underscore initials underscore consent. That will give me the column that contains the information as to what their names are in terms of my participants. And in terms of their decision, the same thing happens here, because decision one, if I go back to my models, this is how I defined it. This is how I called it. So that's why when you go to Heroku and you download it, it comes with that special name. So you cannot label this guy twice. It has to be unique. When you name the first decision one, and you come back and you mistakenly label this guy decision one again, then you have issues to deal with. And I believe Python might even have issues with that. So just keep that in mind. So that will be in terms of what our data says, in terms of understanding the data. This is how it looks like. These are individuals that started with fixed, and along the line, some of them changed their mind. These are individuals that started with random. I think Muntakim started with random, and he continued till the last round where he changed to fixed. And I think I saw Raymond somewhere along those lines as well. Raymond, what did you give your name as?
To be honest,
Is that the
maybe I didn't add my name.
Yeah, I think so. Okay, then. So this is how most of you did play, and my objective for today is to see how our AI will go in line with this data set. So I will just make sure when you download this data, just pay attention to the these rules, rule 14 and rule 27, because this captures the salient points, how they change across those lines. And lastly, the final two rules. And I define what each and every number means. And just a quick one, you see one here, because when you go back to my data, or you go back to our data, we labeled all the fixed information as one. So that's why we see 1 and 2 over there. So just keep that one in mind as well. Yeah, so that will be in terms of our data and how our data will look like. If you have questions, if you have concerns, just let me know, and hopefully we can be of help. Questions? Questions? No questions? Then that's good news. Raymond, no questions, I believe, right?
No questions.
Good. Now let's quickly finish up by looking at the AI. Just a reminder in terms of how I formulated the AI, as in how I taught my robots will go in line with this decision making. So last week I introduced you guys to the idea, as in how I formulated it. So just a reminder, I'll go through it quickly again, and let's see whether it's consistent. So from last week, we had this guy here. Yeah. So let me open it up. Where's my naive AI? Yeah. I said, I believe that there might be two types of individuals, an individual who might go with a random, or an individual who might go with fixed. So to be consistent with our data set, Stacy, for instance, might be an individual of type 1 because she's going with fixed. So that's the same idea I have here. Stacy might be labeled as a fixed type, and Muntakim might be labeled as a random type because he started by playing random. So these are the two types of individuals that I have within the setup. Now within this setup, what is the probability of having a participant who will come in and start playing random, and the probability of an individual who will come in and start playing fixed? out of my own line of thinking, I just place 50-50%. So 50%, I have an individual who might be labeled as fixed, and 50% I have an individual who might be labeled as random. And again, this is consistent with the data set, because out of the total amount of people that I have, which is around 21, 11 of them went for the fixed decision for the first round, and 10 of them went for the random decision for the first round. So this is consistent. So 50% might be labeled as fixed, and 50% might be labeled as random when they start. Now, how many players do we have? As I said, just to be consistent with the data set, I think around 20 people or so. So I'm going to put 20 here. Now, this guy here is very important because remember the number of times that you were asked to make this decision. So you made it for the first round, second round, up until the fourth round. So here, when I come to formulate my decision making for my naive AI or for my machine to go through, I would like it to go through the 4 decision making as well, just to be consistent with what the human beings also did. So we have 4 decision making as well. So this will just be the setup, as in the type of individuals. And I said as they go along, there's a chance that they might change their decision due to what they receive. So if I have an individual who happens to be a random individual, and for the first round he plays random, and his income from the random is higher than the income for the fixed, he will still go with the random. That's my belief till the end. And the fixed guy will also do that. But the trouble will come in when the random guy starts playing random and he starts getting lesser than the fixed. Then there's a need for him to start changing his mind along those lines. So that's what we spoke on Wednesday briefly. So today we have to go through each and every line of code that will do this thinking for us. So that's what I'm about to start right now. If you happen to have questions, let me know. No questions, I believe. So let's quickly start by going through the line of code one after the other, and I'll transfer you guys to extra packages that might help you get, better understanding of the functions that I developed. So I'm going to start by clicking on this guy. Please keep an eye on the name that I give them. So here, with this function, what I need to do here with this first line of code is I need to generate the type of individuals with their probability. So for now, I just wrote this, and there's nothing more interesting about it. What I need to do here is to introduce you guys to the idea of zip, the idea of random, the idea of types of seed, and the idea of the if command, the else command, which we saw on Monday. To start with, I've already defined these guys, so that's fine. But what I need to do here is get them. Get a function that will work such that I have the individuals being joined together with the chance of they playing. So let me run this guy, show you guys the results, and do a reverse engineering of it. So I'm going to run this guy. Okay. So this is the result, right? So it took some time to run, but that's fine. So here, what we have here is within this function, I first of all run what I call a zip. So here, remember, this is a string, right? Because it has only random and fixed, which are letters. And this is a probability that counts with it. So when you do a zip will be able to capture both the first guy here and the second guy together. So even though this guy here, I have random and I have fixed joined together within the same list, what I do here is by zipping them up, by saying zip, I will now match the random with its probability, which is 50%, and I'll now match the fixed type with its probability, which is 50%. So that's what you see here when you run the zip command. So that's what the zip does. So this zip will give you this result. So I have the random coming up with 50% chance, and I have the fixed, which also comes up with 50% chance. So when you see this function, the very first thing that it does is to do the zip. Now, the next thing that it does here is it will try as much as possible. We will try as much as possible to draw a random number. And by that, I'm going to draw any number between 0 and 1. So if you want to draw any random number in Python, the function that will help you draw a random number is random. If you want it from a uniform distribution, then you say random.uniform. If you want it from any other distribution, you might find the tutorial link that I gave you very useful, either from random distribution, from whatever distribution that you might want to have. For here, I'm drawing a random number. So when you run this line of code, which is 16, and you print it out, you realize that a random number has been generated for us, which is 0.378. Now, this is where the main action starts. So this is the cumulative probability. So I start from scratch. I use the for command. What it does is it looks into the zip, and if the number that I generated, which is x, is less than the cumulative probability, then I break. If not, it goes on. Then it gives me a final result. So because they all have 50% chance, I might draw a random type with a 50% chance or a fixed type with a 50% chance. Now let me change the probability of getting a random type as 1 and a fixed type as 0. So there's no chance that I will get a fixed type when I change this number to 0 and this number to 1. When I run this line of code, when I copy them and I run them, we tend to see that no matter the amount of times that I run, I always get a random because there's no chance of getting a fixed guy. So to better understand this line of code, as I pointed out, there's a need for us to understand what a zip command is. So as we try to understand Python, this is what I mostly do. You just go to Google, just type zip in Python, or you can use what I gave earlier in terms of the tutorial code. Now you see command that will help you better understand it. So an example here, if you happen to have a number and you happen to have a letter, just like what we saw in our case, by using the zip command, it can join the number. See, the first number is 1 and the first letter is A. So it will join the A and 1 together for you. 2 and B, 3 and C. So that's what the zip does. The next line that I would like you guys to understand, as I pointed out, is the random. So again, if you want to understand how a random works in Python, very simple. Either you use this tutorial link, or you can just use your Google search and say random in Python. And again, here I'm going to show you guys the type of data set that counts with it. So so these are the random functions that you might have. And again, here it's more intense in terms of how it generates the numbers for you. So just keep an eye on that. And this is what I'm talking about in terms of whether you're trying to get a uniform distribution, regardless of the distribution, no matter the distribution that you are interested in, there's a Gaussian. So just keep in mind how to generate those random numbers. So what I did here, what this function does here is it gets me the type with a given probability. So let's try by giving this guy 0 and giving this guy 1 and run it again, and let's see what we have here. So because the random type counts with the probability of 0, there's no way I'm going to draw a random type. I for sure have to draw a fixed type. So that's why this guy is also fixed. So I'm going to pause here, look at the code, see whether you understand it, If you have issues with it, please draw my attention and I can help you guys discuss further. Questions in there, guys? So this is what we started with. So this is the very first line of code that gets us the type, whether you are a fixed type or whether you are a random type. And for now, we are setting it at 50-50% chance. Item here represents the first part, and then we have the probability that goes with it. Raymond, questions or is okay?
So far, so good.
Good news. Now, this is the first part. This is the first part of our thinking in terms of how we think that the AI will go. Either it chooses a random type for us or it chooses a fixed type for us. The trouble here is when you run this line of code, when you run it, what it comes out with, it just gives you one type, only one type, right? It just gives you either you are a fixed type or you are a random type. But we want it to generate the 20 players that played the game for us, right? We have 20 individuals here, but with this function, we only have one individual. So to do that, we go to the second line of code or the second function. Here, we go a step further by using the function that we generated earlier. So remember, this function is what we saw here. So keep this guy in mind, selection for I, initialize. So trying to get the initial types for us. That's the same function that we saw here, which is the same as drawing the types for us. So we have this function, which is here. But remember, a function within a function. So this is a function that will draw the type for us. Now, our main concern here is we want 20 types, right? We want 20 type of individuals to come in and play the game for us. And this function only gets one person for us. Now, how do we get 20 type of individual to play for us? It's very simple. This is where the idea of while command comes in. So I introduce you guys to if command. You might want to read more on while command. So you just go here, go to the tutorials that I gave again, go to loops and check what a while loop does. It does something for you. While that condition is true, it keeps on going. It keeps on going. It stops when the condition is no more active. It's just more or less like the if and else command, but this will take some amount of time to get there. So an example is here. If it's less than 6, you might want to print I equals 3. If it is not, you keep on going. So just have a look at this code. And again, I'm going to post the while loop here, which I think might be relevant on my website, and see how it works. Now, how does a while loop works for us here? We are interested in getting 20 types of individuals. So we would like this guy here, which is the initial function that we created, in getting the types for us. We would like it to go for a given amount of times. So initially when we ran it, we only had one type. The intuition here is we would like it to go for a given amount of time. Now, given that we had 20 players playing in, we will just ask it to go for 20 amount of times so that we get the 20 type of players to go through this game for us. So how will that work? We start by using this while loop, and len basically tells you that the length of the list. An example of len here is I have only two elements here. So when you type len of anything, it will just give you the list, the number of elements within that particular list. So I'll show you len very soon. But for now, just keep in mind what a len does is it counts the number of elements within a list for you. So the command that you are giving Python here is you are telling Python, hey, while the length of this initial list happens to be less than the total number of people, keep on generating the type for me. Keep on generating the type for me. And what append does is whenever a type is being generated, append will try and then attach it to this list. So this is what we have here. And at the end of the day, we end up with the final list. So just a reminder, what this function does is First of all, we type anything that we would like to type. I'm going to call it copy, and I'll label it as an empty list. There's nothing in there because I now have to start generating the type. So when I do that, I use this command while the length of this guy for now, which is 0, is less than the length of the total number of people that I'm interested in getting them use this app, which happens to be 20. Keep on generating the types for me. And whenever you generate a type for me, append it. That is, add it to this empty list for me and tell me how many lists I have at the end of the day. And when you do that, you end up with your function nicely given to you. So let's do that and let's see what we have here. So I'm going to print this guy here and let's see how it will look like. So just by way of reminder, we now have the initial function, which is from here, plus this new function that will generate the 20 types of individuals for us. Copy everything. I run this guy. Let's see what we have here. So what do we have? You can clearly see that. I don't know whether you can see it from my end. So you can see that there is, I'm going to copy it and paste it here. So you can see that it generated random, random, fix, then random, random, fix, random, till the end, 20 types for me. So that's how to generate the 20 types of players for yourself. So let's try a new exercise wherein we are interested in getting only 5 types. The total number of people that we expect to see is 5. If that's the case, we put n to 5. Put this guy here. Then run it to see what the result is going to be. So when I run it, you tend to see that I end up with only 5. So if you have any question as to how this works, please draw my attention and I can be of help. I'm gonna hashtag them. Yeah. I don't want to see the print anymore because we are done with the top ones. Yeah. So let's try them again and maybe change the number or keep the number at 5. And you can see that I came up with 5 types. The first type was a fixed type. When it did again, I had a random type. I had a fixed type. I went ahead with a random type and a random type. So at the end of the day, I have 2 types who happen to be fixed, and I have 3 types who happen to be going with random regardless. Questions? So we are done with the second function that will generate the number of types for us. If you happen to have any question, just let me know. Questions in there, Tori? Questions in there, Raymond?
Nope.
Is Constantine in today?
No, I don't see him here.
Okay. Yeah. So this is how to generate the types for us. This is how to generate the probability and then the types. Now let's go to the third line of code, right? Let's go here. Now, after getting the types for us, we would like to count the number of individuals within this set or within this list that happen to be random and the number that happen to be fixed, right? So that's the whole idea here. For now, we cannot tell, even though we can tell by looking at the results, it's so complicated. You have to go in there and start counting one after the other, which is just too much. To do that, you want to use this function. So what this function does is, first of all, we are going to use the function we just finished creating. This guy here, producing types. We are going to use him here. So we understand him now. And what we are going to do here is we are going to label the results that we get from it as draw. So the draw here is the same as what you see here. What you see here, I'm going to call it draw. Now I'm interested in getting to know within this draw, which happens to be everything here, how many of them are random. Then I put them in a special list. Then I go again within the same draw, how many of them happen to be fixed, and I put them in a special list, which I call fixed selected. So Random selected means random selected from the draw, and fixed selected means the fixed type selected from the draw. And as I pointed out earlier, if you are interested in counting how many random or how many elements we have in the random set, just this function len will help you do that. Len will help you count. So let's do that. But before we do that, we just have to go back and copy everything that we have up until now. So I'm going to copy it and put it within the third line of code. The third, the third guy here. Okay, so I'm going to hashtag all the prints and keep the print for the third line active. So I'm going to copy these guys here and run them, and let's see what comes out of it. Good. So there's no print, which is good. Now let's unprint all the guys that we need in the third line of code. So we first of all see the draw, then we see the special list out of the draw, which happens to be random, and the special list, which happens to be fixed, and we count them at the end of the day. So let me copy everything and run it. So this is what we have. So remember, I'm using 5 individuals now just to make everything simple. So I have within the 5 total players, I have this fixed type, fixed type, fixed type. And I have random, random. Again, is it consistent? Yes, because 2 happen to be random, which is 1 and 2, which is here, and 3 of them happens to be fixed, which is 1, 2, and 3. Now, what is the length? Simple. 2 for the random, 3 for the fixed. So that's what the third line of code does. So again, this line of code is just basically counting, find the random for I, for every element in the draw, if it is indeed a random. Just put it in this set for me. So that's what this line of code does. And the same thing happens here, and you finally end by counting them and having to realize how many there are. If you put the number to 20, which is a lot, and you run it, let's see what we have. We have a random types, which happen to be 12, and we have fixed types, which happens to be 8. So the same idea. Just keep in mind how these lines of code do play out. So if everyone is okay up until now, then I would like to go a step further to generate what I call the strategies and the weights. So I'm going to copy this guy here and explain it to you guys, what I mean by that. So this will be the fourth function, which basically generates the line of thinking that I have for any fixed guy, and the line of thinking that I have for any random type. So how does that work? I call this function generate strategies, weights, and random. So here, it takes care of all the random types, the number of random types that I have. Now, what I do generate here is this special function, which is more or less like a tuple. So here, because this function is interested in only the random types, whenever I'm interested in generating their strategies and how they will play, if it happens to be a random, my line of thinking here is you will give a fixed decision a probability of 0. If I'm a random type, there's no way I'm going to play a fixed decision. If I'm a random type, I'm going to give the random decision a weight of 1, which is like 100%. I'm going to play 100%. So this is the nature of how a random type plays. What about a fixed type? A fixed type, whenever we call upon him, he's always going to play fixed with a probability of 1. There's no way he's going to play random. So that's why random is 0 here and fixed is 1 here. And the opposite is the case for the random type. He plays fixed of 0 and he takes the decision for random to be 1, 100%. If it's okay with us, then we can copy everything that we've done up until now, which is everything from first line of code to the third line of code. Place it before these guys and see what we have here. So we have, let me hashtag the prints for all the code previous and run what I just finished developing. So everything up until now has been hashtagged. The most important thing here is getting to know the strategies that they come with. So I'm going to copy it. Assume I have 5 players just to make things much easier for us to follow. Copy it and run it again. Now this is what I have, right? So the draw that I have is random, random, fix, fix. So the random type, I have 3 of them. So the first guy here is always going to play 1 for random, 0 otherwise. The second random guy is going to do the same. And the third random guy is also going to do the same. What about the first guy? I have 2 of them. The first guy is going to go with fix with a probability of 1. The second guy is going to go with fix with a probability of 1 as well. So this is how they will play out. So this is what they have in their brain when they come in as a random, and this is what they have in their brain when they come in as fixed. If you have questions, please let me know. If there are no questions, then we'll pause here, take 5 minutes break, then come back and finish the next 4 lines of code, which is very simple. If everyone understands everything from 1 up until 4, the next 5 lines of code will be easier for us to understand as well. Then we finally see their decision when we combine all the codes together. So you can take 5 minutes break, and I'll be back to take you guys through it. If you have questions, I'm going to be here. Please feel free and ask, and we can look at it further. So 5 minutes break, guys. And yeah, okay. So let's see how to continue with it, right? So for now, we now need to go to the next line of code. So remember where we ended. We ended by looking at the types that you can generate. And I think Tori asked a good question. So let me just reiterate about on that. So this is a type that you have. And you have either an individual going with fixed or an individual going with random. So this is basically the type of data set that comes with it. And these are the line of thinking or what they have in their minds. Now let's go to the next line of code, which is how they play out. So if I propose that an individual has a mind which has either going with fixed or either going with random, the question here is, how is it going to play out? And what function am I going to use? So the same idea that we generated earlier in terms of the probability is what we are going to do here as well. So remember, this is an individual that we might want to call a random type, right? Because he comes in with the mind of always going to play 1 for sure and 0 for the fixed decision. So this is more or less like a random type. And this guy here is a fixed type because he goes with a fixed guy with a probability of 1 and 0 otherwise. Now the question here is, if we are able to generate this weight with the probability as well as the type attached, how can we select what they will play at the end of the day? And the answer is very simple. Use the same probability decision that we generated earlier in terms of getting to know the cumulative probability, picking up the X value, and if X is below a certain threshold, he goes for 1, and if X is above a certain threshold, he goes otherwise. So that's how that one will also tend to play out. So just keep that in mind, and let's see how it will show up here. So let's take this individual, right? So I have two types of individuals here. This individual is the random type, and this individual is the fixed type. When I run this function, let's see what comes out of it. If you run this guy here, you tend to see that what we propose is consistent, right? At the end of the day, he's playing random because he's a random type. He's going to play random because he's a random type. And this guy here, because he happens to be a fixed type, he's also going to play a fixed decision. If I change the weight from 0 to 1 for the fixed type, and I change this guy, and I leave this guy as he is. Again, because this guy happens to be 1 for the fixed, and this guy happens to be 1 for the fixed as well, and they both give random 0. Otherwise, when you run this line of code, you should see that fixed comes out regardless of what the decision is. So that's what we have here, right? So this is how they play out. So this line of code is very much in line with the line of code that we saw here. So if you want to understand the decision that we saw in 5 or the Python code that we saw here, just go back to 1, see how it plays out here, and you tend to see that the two are consistent. My worry here is maybe most of you might not be very much in line with what the data structure looks like in terms of whether you have a list or you have a tuple or you have a usual data set. There, my advice would be very simple. Just go back to this guy here. Please spend some time looking at the data set. Again, you might want to look at loops, which we looked at earlier, or you look at whether we have tuples. Yeah, so you can look at tuples here. Yeah, so this is considered a tuple, and that's the data structure that we tend to use. So just keep that in mind as we go along. And this is a list, which is also consistent with the data structure that we have. You might want to go to the list version, look at how it looks like. It's very simple to understand given what we just did. Now, if you are done with this, why not go to the next line of code? And this is where I believe we should spend some time analyzing how the line of thinking of these guys go. Now, this is what I propose. You might want to think of it differently, and let me know. I can change it if the line of thinking is not consistent. For the fixed type, this is what I think he does. Initially, I generate him. He comes with his line of thinking. He's always going to play fixed. Fixed is 1, random is 0. Then, during the first round, he gets a profit. And what is his profit? His profit is basically the difference between the fixed amount that he was given. Remember, the fixed amount that was promised was always 100 in our app, minus the amount that was generated from the random payoff. So what he does here is he does a very simple math. He subtracts the random payment from the fixed payment. Then he does 1 or 2 statistics here. And how does the statistics work? It's very simple. He computes a probability for the random. So this is the amount. So whenever you see I here, the I is from the random payoff. So I divided by 100 plus I is just like you saying that the random amount divided by the total amount that I received. So the random plus the fixed, when you take the random payments and you divide the 2 by the total, then you have what we call the random probability, the probability of playing random. What about the probability of playing fixed? You attach the payment from fixed plus the payment from random because they both have the same denominator regardless. Then to know the weight to assign to your fixed, you just take 100 and divide it by the total. That will give you the probability of playing a fixed. An example is, if in the case of the probability for the random, if the random gave you 100, if the random gave you 100, and the fixed was also promised to be 100. Then the probability of playing a random is 50%, and the probability of playing a fixed is also 50%. They all have equal weight. If, for instance, the random gave you 150 and the fixed gave you 100, then the probability of playing a random is going to be 150 divided by the total, which is 250. So that's how to think of it as you approach this code. What is the weight I assign to my random payoff, and what is the weight I assign to my fixed payoff? If you happen to have any question along those lines, just let me know. This is how I tend to formulate it, as in what the weight that they tend to give to their payoff. So we have the random payoff weight, or the probability, and we have the fixed payoff probability. So he does this math, put it in his mind. The question here is, when will he use this math? And I propose a very simple line of thinking for him along those lines. I go like, he looks at his profit. Whenever the profit happens to be positive, that is to say, whenever the fixed amount, because he happens to be a fixed, whenever the fixed amount happens to be greater than the random amount, and he's always a fixed type, he's always going to maintain his strategy because nothing has changed. He was a fixed type, he played fixed for the first round, fixed gave me a higher payment, so he's okay with that. It's not going to change. That's this if command. Else, if he happens to go with the fixed decision, which he's supposed to do because he's a fixed type, and he realizes that indeed this fixed payment gave me a lower profit, then he might start to think along the lines of, hey, maybe I have to change towards a random. And how does he do that? He just starts changing this zeros and one. Instead of one, he's just going to give the fixed guy a probability of the fixed, which he computed earlier here. And for the random, instead of it being 0, he will change it and replace it with the probability that he computed for the random. So that's his line of thinking for the fixed guy. What about the random type? The same decision-making process. First of all, he computes his profit, which is the difference between what he had, given the fact that he's a random guy, minus what he would have received if he were to go with the fixed payment. So this will be his profit. Then again, he comes in, asks himself this very simple question. What is the payment that I received from the fixed? I do this simple math. What is the payment that I receive from the random? I do this simple math by assigning the weights to them. Then I come in again, ask myself the very simple question. Now, what is the profit that I receive from playing random? If the profit happens to be greater than 0, and he happens to be a random type, then he still maintains his type. He doesn't change. The next round, I'm going to go for the random decision for sure. Nothing would have changed for him, right? So this will be his line of thinking. I'm a random guy. I played random. Random gave me a positive profit more than fixed. I'll have to go for the random because my biases has been proven right. But if it goes against him, which is the else command, then he does the same thing as what we saw earlier. Instead of this guy being 0, he now considered the fixed by giving it a certain amount of probability, which is what he computed here. And for the random, he will give it a certain amount of probability, which he computed here as well. And at the end of the day, we have this function that captures the two. So just to make things much easier for us to follow, what I did here was to separate the two functions. Even though you could have used the same function for both, I tried to separate the two functions. And if you have a different line of thinking, you might want to change the numbers, you might want to change the probability. That's up to you. This is mine, but I might be wrong. So this will be the function for the fixed guy, and this will be the function for the random guy. And we end up with this guy here. So we might want to quickly go back and insert in whatever code that we saw earlier. Is that okay? If you have questions, please let me know. I would like to pause here. If you have any disagreements or any confusion as to how we generated this line of thinking, just let me know. So you just remember, this is what they'll be doing for the subsequent rounds. For the first round, just like what Tori asked, they just come in. If you are fixed, you go for fixed. If you are random, you go for random. But moving forward, you have to assess what the result happens to be in the first round, and you do the assessments using this function. So I'm going to pause here. If you have any question, please shoot it, let me know, and hopefully I can be of help. Questions? Raymond?
No questions.
Yeah. Sorry, is there a question in there? Stacy? So just let me know if there are questions, okay? So I'm going to pause for some few minutes, have a look at it. If you have questions, just draw my attention. Have a look at it. I'll come back to it and have a look at whether you guys have questions along those lines or not. Raymond? Raymond, are you there? Yes. Can you hear me?
Yes.
Yeah, please let me know if anyone has any question in there, and hopefully if I can be of help, I'll do that.
Yeah, no questions.
So if we are done with this code, then why not quickly try and then access the next line of code. So this line of code is very simple. What I intend to do here is go through the counting, getting to see how many individuals will go for the fixed and how many individuals will go for the random. So I tend to call it the count fixed random, and it just takes into account the number of individuals that went for fixed and those who went for random. So just keep that one in mind as well. So this is fairly easy. The copy.append does the counting for you. And then, yeah, start by counting whether you are fixed. We have a very simple container that takes care of the fact that I have nothing in there. And I start by looking at those who selected fixed versus those who selected random. And I count whenever you select a fixed, I give you 1. Whenever you go with random, I give you 0. And at the end of the day, I sum my copy, getting to see the number of individuals that went for the fix, and that will be simple to count. So just understand this function, nothing about it in terms of its intricacies. So this guy is okay, this guy is okay. Almost all the functions that we had up until now should be fine for us to follow. The last function here combines almost everything that we've done up until now. So here, the same idea, we now have a function within a function trying to capture almost everything that we've done from the first line of code to the very last line of code. So what do we have here? We have the main function, which takes care of almost all the elements that we are supposed to have, whether we have the types, whether you are a fixed type or a random type. And then we go to the probabilities that we assign to you when you happen to be a fixed versus when you happen to be a random. Then again, the number of total participants that we expect to see within the setup. For now, we have 20. If we happen to have a lot of guys, we go for the number that comes up with it. And lastly, the decision-making process. Remember, we have 4 decision-making rounds. So that should be consistent with this. So within this main function, this is where we generate the first round, this is where we generate the types, and this is where we generate the subsequent rounds. So we start by looking at the basis of it. We start by drawing the player types, which is the producing types, which is just coming from this second line of code. Just keep an eye on this guy, which is the combination of 1 and 2. So this is what we have here. Then we count the number of individuals that happen to be random and put them in a special set that we call random. Again, we count the number of individuals that happen to be fixed within this setup, and we call them fixed selected. Then we go one step further and count the number of random guys within the random set. Yeah. Sorry, do you mind using the mic?
Yeah, I can use the mic.
Sorry. Yep.
I'm just not quite understanding what A is in the payment profit random and payment profit fixed.
Yeah, sorry. We are looking at the profit you said, right?
Yes, payment profit fixed. So when you enter in that function, you're passing it A. I'm wondering if you can clarify what A is.
Oh yeah, that's a good question. Is it this guy here?
Yeah, I was looking in the if else statement in that for loop.
Yeah. So that's the input. So that's a good question. So here, what the A does is a special list, right? So let me take you back to the line of code that I just deleted. But let me see whether I have it here. Would that be the 6th one? Yeah. So this is where the A is, right? This is the special form, right?
Okay.
That's the input. Yeah. That's the type. Yeah. And
that's at the current state.
Yeah. That'll be the very first stage, right?
The very first stage. Okay. So okay. So then the first item in this list has 2 items. The first item is what the state this person is, whether they choose random versus fixed. And the second is the probability. And then it goes to the next person. Okay.
Good. That's a good question. So here, for instance, this guy here, you see 2, right? You see fixed with 1 and random with 0.
Yes.
Right? So this guy is considered one person, right? But he's considered as an individual. But his line of thinking is what's being captured here. So this bracket from here to here captures only one person. He's thinking of playing fixed or he's thinking of playing random. But the fact that he's playing fixed with probability of 1, we are confident enough to call him the fixed type.
Right.
It might be the case that he might come in with his line of thinking as 50-50%, right? Playing fixed with 50 and random with 50. In that case, we are not very sure as to what the type is.
Mm-hmm. Right? It'll be random 50-50 at that point.
Exactly.
Okay.
Yeah. Perfect. Yeah.
Okay. Thank you so much for clarifying.
Sure. So yeah, if you have further questions, just let me know. Hopefully we can have a look at it. So here, everything that we have here, this main function combines all the functions that we had up until now. The very first function up until the 7th function, I believe. So in this case, we have, for sure, the types, the strategies that they come with, whether you are a fixed guy with your strategies, whether you are a random type with the strategies, we print them out to see whether our line of code is consistent. Now, this is where I would like you guys to pay attention because this might be fairly new as well, but it's not as complicated as you think of it. Just think of it as the situation where we had the copy, right? Where we had this guy here. You start by having a very naive copy. This guy here, this is a very empty list. But as you go along, you keep on attaching your results to the list. So here, for instance, we call this list copy, and we started by making it empty. There was nothing in there. But as we do this math or as we do this computation and we keep on appending, we try as much as possible to transfer all the results to this copy with this append command. And at the end of the day, it will be a list full of types. The same idea holds here. I start by having a container which counts the number of fixed guys. But because this is the first time starting, I don't know. So I for sure have to make it empty. As I go along for the first round, second round, third round, and the 4th round, the list will keep on updating and then all the results will be transferred in there. So the same thing happens to this guy. This is also a container or a copy, you might want to call it, or an empty list. it contains almost nothing, but as the round progresses, we tend to update our list. And the same thing happens to this guy, the same thing happens to this guy, the same thing happens to this guy. So these are basically empty lists, and they are in there to help us capture the results that we get at the end of each round. Now, as I pointed out, this individual has to go through this decision 4 times. So you use the for the for loop. So for T in the range of this, so in the range of 4, right? We are going for 4 different decision rounds. So for the first round, which is a very unique round, we start by picking up the types and the strategies that they come with. So that's what we have here. We have this function which counts whether the number of people who went with fixed and the number of people who went with random. Remember, the input here is STWT, which is the strategy, and then the weight attached to each strategy for the random types. Where do we get this guy? It's very simple. We get him up here. We generate him within our main function. So this function, this guy here will give us what we need to feed to this equation. So this is what we have here. So this function has the input coming from what we have here. So the first round, nothing, we just feed in those guys. Again, within the first round as well, we have to feed in the strategies for the first guys. And that's also coming from what we did up here. We generated a strategy, we had the weight assigned to them, we had the number assigned to them, and that's more pretty much easier for us to feed when we come to the first round. So that's what we do in the first round. Then this function here, that's a very simple math. Because I'm interested in picking up the number of guys that went with the fixed decision for the first round, I define a very simple math that captures the count for the fixed and then the count for the fixed. So the number of guys that happen to be in the random set that went for the fixed, and the number of guys that happen to be in the fixed set that went with the fixed. I call it the sum fixed decision. Then, because of what we did earlier in trying to assess their decision making for the subsequent round, there's a need for us to pick up the payment profits decision, right? So we pick up everything that happened in round 1. We pick all the statistics as to what their profits were, what the outcome happens to be for each and every one of them, as well as the weight that happens to be for them. And this is going to be very important, the strategy and then the weight update. This is no more 1 and 0, which happens to be the case for the first round. This is now going to be in terms of numbers, as in terms of 0.5 or maybe 0.4, because here it comes up with an actual profit that they compute. And with this profit, they have a different probability, which might no longer be 0 and 1. So there's a need for us to update their thinking, just like what we saw in the profit function. So this might be a bit tricky, so just make sure you ask questions for clarification if you have any. For the fixed guy, for the first round, there's nothing to worry about, but when he's done with the first round or given the decision that he sees in the first round, he needs to update his thinking. And he does that by computing the profit and assigning a probability to each and every decision. And at the end of the day, he tends to update his strategies as well as the weight. And when he does that, this is what happens. Remember the empty set that we saw earlier? He comes in for the random type, they come in and they put in the new strategies here. That's why you see the container.append. They put in the new strategies in there. The same thing happens for the first guy. They append and attach their updated strategies. Instead of 0s and 1s, it's now full of probabilities and complicated math, as you might want to call it. And the container for the number of people who went for the fix is just the counts, just like what we saw. So these guys happen to be empty at first, but now based on what we just finished doing, we now have some numbers to feed it for the first round. Now they come to the second round, which is round 2. And remember, within round 2, we don't have to generate whether you are a fixed or you are a random. We've already generated you. We are now interested in seeing how your line of thinking goes. So for the random type, for instance, what is going to be their strategy and what is going to be their weight? And the answer is very simple. The strategy and their weight is going to come from the updated strategy and weight that they did by playing round 1. So that's how come you see this container and it's picking up all the strategies that they had in round 1. Right? So this strategy container, when they come to round two, which is the second round, this is more or less like having a new set of strategies that they would like to go with. Instead of using my zeros and ones, they are now going to use their probabilities and they should be fine with that. If there are any questions, please let me know. The fifth guys as well, when they come to the second round, they are no longer going to use the zeros and ones that I gave them. They are now going to use the probability that they computed, and that's how come you see this STW. So technically, this STWT for round 2, round 3, and round 4 is different from this STWT for round 1. And this will be the case for the subsequent rounds, and they will keep on doing that for the next 3 rounds. And you realize that I don't necessarily have to write the subsequent rounds, because as soon as we get to the second round, everything becomes just a routine. You just do the math and you go back to it. You just do the math and you go back to it. Round 1 happened to be special because the machine is using what we gave it, but from round 2 to round 3, they now have to keep up changing their decision by themselves. That's why we don't necessarily have to see t equals 1 or t equals 2 to t equals 3. This command suffices that. If anyone has any question in there, please feel free, and I'll be happy to come in. Yeah, you.
Yep. There's. Can you see it, Farouk?
Yeah. If you might want to read it, hopefully that might.
Yeah, sure. So Yui says, my understanding is that the AI codes here are simulating what users would do when they use our app. What I don't understand is, why are we simulating this process? Can't we just analyze the data we collect from the app?
Yeah, that's very consistent, right? So what you're asking is very good, and that's why I first of all start by calling it a naive one, right? So to do that, you have to go through 3 processes, and I like the question. You have to go through, first of all, getting the data. Secondly, do a grid search, and when you do a grid search, you pick up all the parameters that you might want to assign. And lastly, you try as much as possible to fit the data to whatever simulation that you have and see how consistent the 2 are. But for now, I'm calling it a simple AI because I'm skipping the research aspect of it, right? So that's why we call it naive. So when you go to my website, I have what we call the genetic algorithm. Let me see whether I have it here. There, we have a more sophisticated approach towards using these algorithms. So let me see whether, yeah. So I have you can download the code here. Hopefully it's downloadable. Yeah, you can have a look at this guy here, which is the cobweb, or you can have a look at the voluntary mechanism with the code. I think I have the code uploaded as well. So that's equally, applicable. For now, we are skipping the grid search aspect of it and going very simple. Is that okay, Yui? Yeah. So this is my code on genetic algorithm, and I think I have the grid search. If you are interested in getting the grid search, let me know. I can send it to you, and maybe you might want to do a grid search of the data that we collected. Pick up the parameters that you think might be consistent with any theory that you might want to use in simulating the data, and let's see how consistent the two are. Okay. Further questions, everyone?
No.
Okay. So let's see how this will play out. Because this is naive, we might be lucky to get it consistent, or we might not get it as consistent as we might want to have it. And lastly, we plot a graph, right? We need to plot the graph. This is the data from the app for the number of people who went for the fix. This is the data for the random type. This is the data for the initial fixed type, and we can plot it. And if you are interested in plotting a graph, you might want to get this package. And getting a package in, you might want to get matplotlib. You might want to get it before you run your graph. If not, you might find yourself in trouble. And to get a package, very simple. You go to settings, you go to this guy, you go to the interface, you see your username. Yeah. If you're interested in getting a package, you click on this guy. So let me take you guys from the scratch. If you're interested in getting a package, click on the files, go to the settings, click on this guy here, the project interpreter, then click on this green line. Yours might be different, but it should be consistent. Click on it. Then you can search for package you are interested in. Maybe you are interested in matplotlib, which I already have. If it shows up, you might want to click on it and you just install it and off it goes. So that's how to download the package. So for our case, I believe you will need this guy here to get your plot up and running. So this is the nature of our code, and let's see how consistent the two are in terms of our line of thinking. So I'll copy everything and I run it. So the graph might pop up. So this is the graph that we have. So so you can see we have lots and lots of variables to pick, but I think they are a bit consistent in a way. So the blue line, for instance, right, is a total fixed decision with a simple AI, and this is the human decision. So you can see that clearly the blue line here, which is the AI, it is going in line with how the humans perform. Even though there's a bit of a gap there, it's not as much. Again, given what we asked, because this happened to be a simple, naive one, I think we are getting there, right? So the blue one and the brown one, or the gold one, you might want to call it, they both capture the total fixed decision that was made at the end of the day. And you can see that they are a bit consistent. Now, if you compare the green one to the red one, they are both interested in capturing the random types and how they behave in terms of moving towards the fixed type. And lastly, the very deep brown one and this guy here, they compare the decision making of the simple AI in terms of you being a fix to the human types. So that's what I wanted to point out. If you have questions, if you need further clarifications, please let me know. Yui, Stacy, or Raymond, sorry, questions in there? So I'll send this code, hopefully by the close of today. I'll get it posted on the website. And if you have any further questions, please feel free. We still have about 10 minutes to finish. Hopefully you might find it useful. So I'm going to be here for the next 10 minutes. If you have questions, please let me know. If you don't, then feel free if you have any other errand to catch up. Thank you, and hopefully I'm going to be here. Just let me know if you have questions. Thank you very much for joining me.